In 1895, H.G. Wells published a fantastic novel about time travel. He entitled it The Time Machine. The book ushered in a fanciful era of imaginary trips to awe-inspiring events of history. '79 A.D., the eruption of Mount Vesuvius. '26 A.D., the resurrection of Christ. '15 billion B.C., the very creation of the universe. Today, science is reshaping our concept of the cosmos. Are we at last ready to journey to the stars and conquer the barriers of time and space travel?
This series presents information based in part on theory and conjecture. The producer's purpose is to suggest some possible explanations, but not necessarily the only ones, to the mysteries we will examine.
We are witness to the last leg of a hypothetical journey to the stars and back again. Our crew has been traveling through the galaxy very near the speed of light. They have finally returned to Earth. Due to an effect called time dilation, first described by Albert Einstein, hundreds of years have passed on Earth, while only a few years have passed in the spaceship. Once they have landed, what will the crew find when they open the portal of their ship? Will Earth have reached undreamed heights of technology, or seared itself back into Stone Age emptiness? It is easy to conceive of the astronauts' journey through space. It is harder to comprehend their travel through time. How far-fetched is the idea of actually traveling through time? Today, we accept the concept of distant space travel because we have journeyed to the moon and back. Now, scientists are preparing for a world where both time and space travel are inseparably linked.
Status check. Command on internal? Affirmative.
One expert on the subject of time and space is William Kaufman, author, lecturer, and adjunct professor in the Department of Physics at San Diego State University.
We all live in space and time. We're all familiar with the three dimensions of space, forward and back, left and right, up and down. And time is what clocks measure. As the clock ticks on, it's measuring time. And of course, as we go from the cradle to the grave, you're also moving through time. It's kind of like looking up at the stars. When you look up at the stars during the night, you see stars scattered across the sky. If you think about what you're seeing, if you look at a star that's 10 light years away, you're really seeing how that star looked 10 years ago because it took the light 10 years to get to you. And therefore, to me, one of the great lessons of the nighttime sky is that as we are looking out into space, we're also looking backwards in time, that we must incorporate time on an equal footing with our three dimensions of space and talk about something that we call space-time, one of the things that was given to us by Albert Einstein.
Albert Einstein changed all conventional thinking in physics when he published his famous theory of relativity in 1905.
E is equal mc squared, in which energy is put equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy.
Albert Einstein approached all of reality with a deep personal conviction, almost a religious belief, that if we're doing anything right in science, if we're discovering anything of any real value, then the way we write down our discoveries, the way we write down our equations, should not depend on things like the color of your skin or your religion or how fast you happen to be moving, whether you're sitting here on the Earth or zooming through the solar system at 3/4 the speed of light. And all Einstein did in 1905 was take everything we knew about electricity and magnetism and rewrite it in a form such that it would be the same for everyone. For an example, suppose you have a rocket ship moving through the solar system at 3/4 of the speed of light. In order for you on Earth and your colleague in that spaceship to have a complete, coherent, rational understanding of how things work, you have to say his rulers are shrinking. You have to say that the very mass of his spaceship is behaving as though it's much more massive than it normally is. You have to say his clocks are ticking more slowly than normal. Not only do the clocks tick more slowly, but every process proceeds more slowly, like the rate at which a man's beard grows, or the rate at which your heart beats, or even the rate at which you age. One of the results of all of this is that you can't travel faster than the speed of light. And the reason why this is so is if you think about moving out in a rocket ship, say a rocket ship even with an infinite supply of fuel, as that rocket ship goes faster and faster and faster, its clocks slow down. And as a result, it burns that fuel more and more slowly. And the slowing down of time is so powerful that at the speed of light, clocks stop, time stops. And as a result, you never are able to burn that final drop of fuel, that final precious drop of fuel that would put you over the speed of light. While Albert Einstein was exploring many of the hypothetical and mathematical aspects of space and time, people in the United States and in Germany were actually building machines to take us up off of the surface of the Earth.
Early experiments in rocketry appear almost comic compared to today's accomplishments in space. But improvements in rocket design came rapidly, especially in America under Robert Goddard, and in Germany with the work of Wernher von Braun. By 1932, von Braun had taken charge of Germany's rocket program and had begun the tests that would lead to the infamous V-2 missiles. During World War II, Adolf Hitler used the V-2 rocket as a weapon of terror against the civilian population of London.
For better or for worse, rockets have always had a military application. But underlying all of this, in the minds of everyone who works on these projects, is the vision of using these machines to take us beyond the confines of our own planet, to explore the moon. We've walked on the lunar surface, to use reusable rocket ships like the space shuttle, to make many trips, to make use of the full potential of what actually exists out there in space. And you know, perhaps not us, but our children may very well be able to book flights to space stations or to the moon and beyond.
One group that hopes to be among the first to utilize the space shuttle when it opens up to civilians calls itself Oasis. They gather together on weekends to share food and their enthusiasm for space travel.
I'm Charlie Carr, and I'm with the California Museum of Science and Industries. This group is doing something that's really unique. It's getting together a lot of people from different backgrounds, from technical fields, from social fields, people working in the community, all different sorts of people, and they're all thinking and talking about space. They're talking about what's going to happen in the future, talking about what's going to happen personally to their lives as more people on Earth move out into space.
A frequent lecturer to the group is Dr. B.J. Bluth, sociologist and expert on long-duration space flight.
The work that I do really focuses in on how people can live in space, how they can get along together, what kinds of general problems, stresses, factors make it easier and harder for them to have a viable, successful mission. The human is going to have certain kinds of problems when he goes to space. There are stresses, there are physiological problems, there are fears, there are incidents that occur, there's the interpersonal relationship, there's being holed up all alone, no place to go, no way to get away. If you can imagine yourself being in a camper with no privacy curtains, with another person for 6 months and no place to go and you can't walk out of the camper, what kinds of things happen in that kind of situation? We have a very human problem in going to space. The technology is only one aspect. And if the human part of this space travel isn't as carefully solved as the technology problem, all of the technology in the world isn't going to make it possible to do what we want to do.
Obviously, there are a lot of technical problems with space travel. It's a difficult business getting someone there and back and healthy and sane during the process. But there's another whole aspect to this business. Because sitting around in the scientific journals for the past 15 or 20 years now have been things like time machines and time tunnels, wormholes in space, highly warped regions of space where you could go in someplace in our universe and come out in another universe, or go in one of these holes and come out back in our own universe at a different time, 1 billion years ago or 1 billion years in the future. And these are some of the most fantastic, hypothetical things that science has ever given us.
In our future explorations of the galaxy, will we one day make the discovery that will fulfill H.G. Wells' dream of time travel? Will we find the mechanism to travel backwards and forwards through time? I am afraid I cannot convey the peculiar sensations of time traveling. There is a feeling of helpless, headlong motion. As I put on pace, night followed day like the flapping of a black wing. So wrote H.G. Wells in 1895 in his incredible novel, The Time Machine. Wells described a machine of brass, ebony, ivory, and translucent glimmering quartz. It was designed to take man on a journey through time. Wells clearly understood the implication of traveling backwards and forwards through the centuries and depicted it as a wonderful adventure. In an effort to accurately predict the future, H.G. Wells strove to utilize the latest scientific theories of his day. A strong proponent of the theory of evolution, Wells suggested that the environment of industrialized England would cause the factory workers to evolve into what he called Morlocks. The Morlocks were pale, pink-eyed, carnivorous creatures who inhabited underground caverns of complex machinery. Wells saw a different fate for those who lived the life of leisure in society. After thousands of years of living without need or conflict, Wells proposed that they would evolve into what he called the Eloi. The Eloi were childlike creatures of limited intelligence who would frolic and gather fruit on the surface of the earth. Today, the evolutionary prophecies of H.G. Wells seem to many unlikely. But is it possible that someday science may actually build a time machine?
Having a time machine is a very attractive idea. We all have things we'd like to go back and change about our lives or maybe affect history somehow. But scientists have trouble with time machines. There are a lot of illogical inconsistencies that develop. For example, if you had a time machine that could take you back 1 billion years in the past, well, then you should certainly have no difficulty going 5 minutes back into the past. And if you could go back 5 minutes, you could meet yourself and tell yourself, literally, what kind of a nice trip you had. And then both of you could do the same thing. And then all 4 of you could do it. And then all 8 of you could do it. In other words, there's an inherent inconsistency that suddenly comes up. If you could travel back into the past, then reality must be irrational. There must be a very irrational part to how the universe works. And we don't see this going on around us. And for this reason, when scientists find time machines popping up in their calculations, a lot of flags go up and they begin suspecting that they've done something wrong.
If there is any chance of a time travel mechanism existing, it will probably be found in distant space. Some scientists believe that when a giant red star explodes, the remaining core may collapse down to an incredibly dense ball of matter called a black hole. The gravitational field around a black hole is so intense that not even light can escape it.
The full description of how black holes work also include white holes. The full description actually is a set of black holes and white holes back to back. What's a black hole for one universe where things fall in is a white hole in the next universe where stuff gushes out. But the interesting thing in all of these pictures where you have a black hole, white hole situation is that if you take into account the effects of rotation on the black hole, the entire structure inside the black hole change. In particular, one of the things to come out of this, theoretically, is that you could possibly use this black hole as a portal, as a time tunnel from our universe to some future universe, or perhaps even some past universe.
Such a journey into a black hole would be fraught with dangers.
If you can go through that wormhole in space and time, then you can travel very, very near the center of the hole. You can travel very near where the matter of the star collapsed down to, where you have this tremendous curvature, this high warping of space and time. And there are problems with that. For example, if you could travel very near that place where you have infinite space-time warping, according to Einstein's famous equation E = mc squared, the energy in the gravitational field of the hole produces a lot of matter that fills up the wormhole and chokes off any possibility of space travel to future universes. And this is one of the ways in which we think nature prohibits time machines. Nature takes care of things and makes sure that things won't come out too irrational by having a time machine. It chokes off the possibility of getting through the wormhole.
Perhaps the tunnel through a black hole will forever remain blocked, but the possibility always remains that someday someone will make a discovery which will allow us to visit Earth's distant past or glittering future. Carol Amato has a background in social science and is a member of OASIS. She has a special plan for accomplishing her goal of space travel.
I use the computer in my work, and I'm hoping that by doing so, this will provide a career path for me to get into space. My children I'm trying to prepare just by being adaptive to new situations. Tracy has a tremendous interest in growing things, plants and baby animals. I'm hoping she'll take this interest into space because it's going to be necessary to want to nurture things in order to make the environment be a psychologically pleasing one and to recreate something of the Earth. Damon's a very active boy. I hope he can utilize that energy that he has in some constructive way. Maybe he can go into space and become one of the pioneers.
With the successful flight of the space shuttle and the likelihood of civilian space travel on the horizon, it is not difficult to imagine families like Carol Amato's someday traveling into space. Perhaps one day, a boy Damon's age will solve the mystery of what lies on the other side of a black hole or at the place beyond the stars. What are the limitations of the galaxy? Will we ever travel faster than the speed of light, or backward and forward through time?
I don't think that any scientist would categorically say, no, we will never travel faster than the speed of light. No, we'll never have time travel. But if we ever do, then this would have to come from a whole new view of science, a new super science, whereby we understand today's limitations as one separate little case. In other words, the kind of science that would give us travel into the past or travel faster than the speed of light would be as advanced over us today as we are over Neanderthal man.